Welcome to the Kusto Query Language full course for beginners. This course will help you understand the basics of the KQL language and enable you to begin writing queries. The 10-minute KQL channel is dedicated to helping level up your KQL skills, no matter where you're at in your journey. If you have no prior computer language knowledge, we recommend going through the 10-minute KQL beginner playlist. The link is in the video notes below. The playlist spends extra time explaining core concepts of databases, computer languages, and gives more practical exercises as well as having homework after each 10-minute session so you can get hands-on practice. This full course will go through each of the core beginner concepts and give one practical example for each new topic. If you have trouble understanding any portions in the course and you want to dive deeper, we'll have links to videos on each topic in the video notes below. KQL is a powerful cloud-native language that's designed to query large data sets. If this is your first computer language, you've picked the right one. Most find it intuitive and easy to pick up. If you're transferring from other languages like SQL, you'll find many similarities, and you'll catch on quickly. KQL is a worm language, meaning write once, read many, so you can practice your queries without worrying about accidentally destroying data. KQL is great for answering questions, triggering alerts, and developing business insights with big data in the cloud. Many Microsoft Azure and Microsoft 365 systems natively use KQL. When querying data sets associated with security tools like Microsoft Sentinel or the Defender suite of tools, there are some questions that can only be answered with KQL. It is not possible using the GUI alone. With connectors, you can ingest data from multiple sources. Cybersecurity analysts and incident responders use KQL heavily to investigate security concerns. Azure resource owners can gain detailed information on the resources. The data collected can help data analysts transform raw data into useful business insights. KQL was named after Jacques Cousteau, the underwater explorer, with a spelling change, of course. To learn KQL, or any language for that matter, you need hands-on practice. If you're practicing on your production environment at work, that's great. If you need a practice environment, we'll show you how to access 2 free data sets that we'll use in the course. These free data sets do not contain any sensitive information, so if you want to ask questions in the comments section, you can paste queries there to learn with and help others. If you're practicing on your production work environment, be mindful of operational security and do not expose your internal network information if you choose to ask questions in the comments section. The first free data set is Azure Data Explorer, or ADX for short, and the second data set is a Log Analytics Workspace, or LAW for short. Each environment has different sets of tables, and the layout of the GUI is different. We'll show both in this course so you're more comfortable using KQL in different applications you might find in your work environment. To access the free ADX environment, navigate to https://kusto.azure.com/public-free-cluster. Sign in with your Microsoft account or sign up for a Microsoft account using your personal email if you don't already have one. After you authenticate, you'll be taken to the ADX user interface. The first thing we need to do is connect to our practice datasets. Click Add Connection and type in the following: https://help.kusto.windows.net. Once the connection is made, you should see the new databases populate. You can expand and contract the datasets and see the hierarchies of clusters, databases, and tables. This hierarchy is important when we begin to write our queries. A table is a collection of records that run horizontally and fields that run vertically on a like subject. A database is a collection of tables, and a cluster is a collection of databases running on grouped resources that can run in parallel to improve performance. In ADX, our data sets are on the left, we type our queries on the top, and the output data set is displayed on the bottom. To access the second free Log Analytics Workspace demo environment, we open up a second window and navigate it to https://aka.ms/lademo. authenticate with your Microsoft account, or create a new account using your personal email address if you don't already have one. You can see some differences from our ADX work environment. On the left, we have three basic options: tables, queries, and functions. Also, if we need more real estate for queries or results, we can use these arrows to contract and expand the left panel. When we click on the Tables section, we can see a list of categories, which our usable data sets are located in. This is different than ADX, where the top of the hierarchy was a cluster name. As we expand any category or solution, we see the tables inside. When we start to write a KQL query, usually we have a question that we need to answer. In order to answer it, we need to know something about the data sets that we have, what they contain, and how they're organized. As we look at our data sets and begin to expand them, once we get down to the table level, we can see what fields are in each table. This is one way to have a general idea of what the table contains. Another way is to type in a table name, take a sample, and see what the table contains. Let's begin writing our first query using the sign-in logs table. As we start to type in sign-in logs, we can see that we receive suggestions from the IntelliSense feature. If we want to use this suggestion, we can hit the Tab key. We see that it completes the suggestion and enters a new line with a character at the beginning. This is called the pipe character, and it serves to take the output of the previous line and use it as an input to the current line. Let's type in take 10 in all lowercase letters, then click on the Run key. Take samples random records, and the number 10 represents how many records it will sample. If we scroll to the right, we can see all the field names, and we can see all the values for each record. This table is showing us all the interactive sign-in activity for our environment. Taking a sample helps us understand what fields are available and the different types of records produced. These are called logs. Every time an action is taken with a system configured to retrieve data, it's recorded in the logs. The logs retain the information for however long the retention period of the logs are set for by the administrator. Common periods of retention may be 30 days, 90 days, or even 1 year, but it can be adjusted based on the need of the company, since oftentimes extending the log retention period costs additional money. Now that we can see some of the fields, let's focus on one called location. It has the country code for where the user signed in from. If we want to filter the data set to only see records from GB for Great Britain, we can use a where statement. We can use one or more where statements to begin to filter down our massive data set and see only the information that we're interested in. As we type in where in lowercase letters, we see IntelliSense recommends it, so we can hit the tab and fill it in. After where, it expects the name of a field that we want to filter on. The name of the field is location with a capital L. When working with field names, capitalizations matter, so be sure to type it in exactly how it looks. Again, we see the IntelliSense picks up this field, so we can hit Tab to complete it. If we want an exact match of GB, we can type in the double equals, which means an exact match to include correct spelling, spacing, and capitalization. Since we know we want GB with both letters capitalized, we can type it in either single or double quotes. We can type a new line with a pipe character and take 10 for another sample. As we scroll over to the location field, we see that only GBs are there, so we know our filter worked. If we want to add a second filter, we can type in a second where statement. On our second where statement, let's type in Azure Portal as the application. When we run this query and scroll to the right, we can see we only have records from GB logging into the Azure portal. We can continue this process until we get just the login information we want. We can filter by username, by device type, by IP address, by authentication type, and many other variables. When we look at what the pipe character is doing, we start with a table name. If we ran the query with just the table name and nothing else, the output would be all the records from the table. When we enter a pipe, it takes the output from the first line and turns it into the input for the next line. As we do this, with more and more where statements, we can visualize a funnel that's slowly reducing the data set to the information we're trying to see. You can see how this process may be useful during an investigation or for identifying use of individual resources. In KQL, the spacing generally doesn't matter, but there's some exceptions. Here we can see that if I add a few extra spaces, the query runs without a problem. And if I take away all the spaces, it still runs. If we wanted to type in more where statements, we could. We could also replace where with and. If we type in multiple where statements, all of the conditions must be true in order for the record to display. When we use and, the same thing applies. All conditions must be true for the record to display. We can also make a stylistic choice to indent ands for ease of readability. It's purely stylistic and has no bearing on how the query functions. When we use multiple ands and decide to place each one on a new line for ease of readability, we don't need to use a pipe character. What if we wanted to see both sign-ins from GB and sign-ins from the US? We could use OR. With OR, if either of the two conditions are true, it'll produce a record. When we run the query, we can see a lot of sign-ins from the US, but occasionally we see one from Great Britain. If we wanted to also see sign-ins from Canada, we could add another OR line. As you can see, adding a new line for each new condition can get old quickly and can make our query pretty long. If we have many conditions and we want to see records if any of them are true, just like an OR statement, we can use in. When we use in, we can use parentheses and place all of our conditions inside. When we run the query using in, we can see it works the same as multiple OR statements. We place a comma between each string, and we place quotes before and after each string value. We can either use single or double quotes, but we shouldn't mix them. Just pick one and go with it for now. When we use the double equals, or in, the capitalization matters. If we change the capitalization and run the query, we can see that it has no results found, because there were no exact matches. Sometimes we don't know the capitalization of what we're looking for, or they could have been entered into the database with different capitalizations. To make our query case insensitive, we can use the tilde symbol. It's located on the upper left of most keyboards and looks like a wavy horizontal line. When we place the tilde after in, it makes all of our conditions case insensitive. Now when we run the query, we get all of our results back. We can do the same test with double equals, but instead of double equals, just place a single equals followed by a tilde to make it case insensitive. If you find this content valuable, we appreciate a like, and if you want to receive updates on new KQL videos, hit the subscribe button with the notification bell. Now let's jump over to Azure Data Explorer, or ADX for short. We'll point out a couple of differences from our Log Analytics workspace. On the Log Analytics workspace, we simply typed in the table name and wrote our query. In ADX, if we double-click on a table, it will populate in our query space. Then we can start to type in our query. In ADX, if you only type in the table name, you have to click on the associated database. Then it will recognize it. You'll find it's best practice in ADX to type in the full cluster database, and table into the query, so you can share the query with others and it'll work right away. When we start to type in cluster, IntelliSense helps us out. We can see that our cluster name is help, so we can type in the cluster and place help in quotes. After we type a period, next we type in database. We type in the database we want in parentheses and quotes, and place another period. Lastly, we type in the table, then we move on to develop our query and run it. I wanted to show you both ways in ADX, so if you ever see this full hierarchy on the first line, you know it's simply a direct reference to the data set the query is pulling data from. Let's pull a sample from a data set in ADX. The Contoso sales database is set up to represent the fictitious company of Contoso, so you can practice querying on products, sales, and customer information. If we take a sample from the customer table, we can see it provides all the customers for the Contoso company, and it has associated personal information. We can see there are a lot of fields. Oftentimes it's too much information and we just want to narrow down the fields to the ones we're interested in. In this case, Project is useful. Project displays only the fields we want to see. If we're only interested in seeing the first name, last name, city, state, and country of each customer, we can project those fields. IntelliSense identifies the field names, so we can tab our way through to speed things up. Now that we've narrowed the data set, if we want to go back, or maybe we want to add another field, we can use the double slashes to comment out the line. When we use the double slash, it comments out everything to the right of the slashes, and effectively takes it out of the query. The commented out sections turn green to let you know they're not being considered as part of the functioning query, as if the information to the right didn't exist. Maybe we want to add one more column with education level. We can uncomment the line, add the additional field name. When we run the query, we can see it populated the extra field. The order of the fields in the project line determine the order of the output. So if we want to change the order, we can manipulate it in the line. We can also place a comment before the query, or to the right of any particular line. This can be useful to remind us, or to inform others, if we share the query, what the purpose of the query is, or any areas that need to be filled in for the query to work properly. When we filter with where statements, sometimes we aren't sure what all the options are in each field, since many of the tables are large in size. One way to find out all the available options for a particular field so we know how to write our where statement is to use distinct. Distinct shows you all the unique values for a field. In this example, we want to see all the unique education values for the table. We type in distinct, then the name of the field, and it provides all the options available from the output dataset. Now we can select one or many of the options and filter using a where statement. When we view the output datasets, the records are often out of order and can be large and confusing. One way to place order and structure to the output dataset is to use sort. We could sort by a specific field or multiple fields. If we type in sort, then the name of the field, and run the query, the default sort type is descending. Descending is in reverse alphabetical order. When we sort by a time field, descending is the newest or latest time value. If we want to reverse the order, we can use ASC, which is short for ascending. If we want to sort by two fields, we can place a comma. Here we see it sorts by our first field, then sorts by our second field in groups. Before we showed how to take a sample of a table so we could see what's in it. If we have a string of information and we want to see where that may be located in our datasets, we can use search. Search uses a lot of resources, so be aware that it may time out if you're searching large databases. We can search a single table, or we can search multiple tables, and even all tables that we have access to. In this example, we'll try a broad search for a device name. Our goal is to identify what tables the device can be found in. When we look at the results, we see a new field of $table. This represents the name of the table the information was found in. We can then pivot to that table, take a sample, and begin to write our where statement to filter for that device. If we wanted to search for a string of information inside of a table, we can place the table name, then pipe in search in this way, and it shows the records with a match. Before we use double equals when we're filtering for an exact match of a string. Sometimes we don't know the full string and just know part of the string. In that case, we can use contains. Contains uses a lot more resources and processing power than double equals, so it's best to use a more efficient option when you can. If you're searching for a string using contains, be aware that it might not always be exactly what you're looking for. When you use contains, it's automatically case insensitive, so capitalization doesn't matter. Another option is to use has. Has leverages delimiters, which are a known set of characters that are recognized as a break in the string and can be used to start and stop each string search. This adds an additional layer of precision above what contains offers. And just like contains, has is not case sensitive. Here are some examples of delimiters. In this example, we want to find URLs that have COM. The period and the space after the M in COM both serve as delimiters to isolate the string. If we use contains, we would also get all of these URLs, but we'd also get many other string values that contain COM in the words that potentially ended in a different top-level domain, like .uk. Another option that works in a similar way to contains is starts with and ends with. If the strings you're looking for start with a set of characters, letters, or numbers to include delimiters, you can use start with. The same goes with ends with. In KQL, the exclamation point represents not or doesn't. If we want to find strings that don't start with, don't end with, or don't equal, we can use the exclamation point. Here are some examples of using the exclamation point with where statements for filtering. When we produce results in a data set, we can see the count of records here, and the time it took to run the query here. If we wanted an output data set that only included the count, we can type it like this. Before we talked about strings, we can also manipulate integers, which are whole numbers. It's possible to have letters, special characters, or numbers in your strings, but there are certain things you can't do with strings, like math problems. When we're working with integers, we can perform math. When we type in a string, we have to use either single or double quotes. When we use integers, we don't need quotes. In this case, we want to filter this field for values greater than 4. In this example, we want to filter for values less than 2. And in this example, we want to filter for values of greater than or equal to 2. If you aren't sure whether a field contains strings, integers, or other data types, you can use getschema. The schema helps us understand the structure of the table to include what data types are associated with each field. In the intermediate series, we'll discuss how to change data types. We've been using ADX for a while, so let's jump over to our Log Analytics workspace now and see what it looks like. A key part of filtering is narrowing down the time span of the logs. Here you can see the GUI is set for 24 hours, so by default the query produces results for the last day. If we need logs for the last week, we can change the GUI settings. And if we need logs from and to specific dates or times, we can also set that in the GUI. Keep in mind the data retention settings for your environment dictate how far back you can query the data. The further you go back, the more logs you need to store, which in many cases means more money you need to spend. Most businesses have a balance between operational need for log retention, security for having logs when you need an investigation, and budgeting to determine the log retention period. While you can set the date time in the GUI, it's best practice to set it in the query. So if you share or reuse the query later, the date ranges are preset in the query, and there's no guesswork or manual setting required that could produce an error. There are several ways to set the time span in the query. One way is to use a Go. If we want to see logs for the last week, we can type in the name of the field containing the date time we want to filter on, then type in greater than or equal to in a Go 7D. We're saying that from a point in time 7 days ago, we want to see records greater than that marker. When we use greater than with a datetime data type, it means more recent or later. If we only wanted to see records older than a week, we could use the lesser than symbol. Common time options are S for second, M for minutes, H for hours, and D for days. Keep in mind there are no week, month, or year options. So if you wanted to see records from 2 months ago, you could use 60D, assuming you had logs retained for that long. A Go is useful if you want to go back a specified time. But every time you run the query, you'll get different results because the period defined as precisely 7 days ago is constantly moving as time moves forward. When you need to start or finish your query at a precise date time every time you run the query, you can use between. Between expects a start and end date time, but you can also reference other functions such as now. Keep in mind that if your selected time frame is before your log retention period, you may get partial or no results at all. When we type in the date and time, KQL recognizes many formats. It's common to just pick a format that you can remember and that works best for you and stick with it. In this example, let's use year, month, day, hour, minute, second format. This format is nice because working from left to right, it starts with the largest time value, which is a year, and progressively works towards the smallest time value, which is 1 second. And it has a capital T in between the date and the time. When we use between, we place our times in parentheses, and we place 2 dots in between the start and the finish date time. When we run this query, we can see that all the dates and times fall within the time span that we've defined. Remember, the first date and time must be older than the second date time, otherwise the query will fail. Here's another option. If we want to see all records starting from one date time and finishing right now, we can use the now function. If you use this, keep in mind that the results will continue to change as additional records are logged, so the results of the query today will be different than the results of the query tomorrow. We can also choose just the time and not the date. If we do this, it's assumed that you're referencing today. It's also an option to use just the date. If you do, it references midnight on the morning of that date. In this query, it is not providing a dataset output beginning with the 5th and ending on the end of the 7th. Instead, it's providing one beginning on the 5th to the beginning of the 7th. Because date times generally require 3 sets of parentheses, they can be a little confusing. Just remember all of your dates and times are encapsulated in one set of parentheses, and each individual date time has a second set. Also remember, when working with times in KQL logs, they're generally kept in universal time, or UTC. This can also be referred to as Zulu time or Greenwich Mean Time. This universal time is often used because companies are global. They span multiple time zones, so logs stored will speak a common language that anyone in the company can understand no matter what their geography is. Let's take a pause now and look at a new data set called VM Connection, which shows network connections of virtual machines in our environment. Let's combine some of the lessons we've just covered so far. We can start off by sampling the data set. Let's make our first where statement define the time span of the last week. We want to look for destination ports of 80. In this case, we chose to use AND, but we could have also chose to use where. We choose to indent the AND because spaces left to right generally don't matter in KQL. We didn't need quotes around the 80 because it's an integer data type. We added another condition where the computer by name we're interested in is defined. Lastly, we piped in distinct process names. With those three filters, we've isolated our search to a single device using a single port in the last week. And we can now see all the unique process names used by that device over port 80 in the last week. You can see this can be useful for troubleshooting, investigating security concerns, or answering big picture business questions at scale in a company. And it didn't take that long to write. We've already discussed using take to get a sample of the data and using sort to organize the data. Sometimes we want the first 10 or first 100 records from the output data set, and we don't want random records that are associated with take. In this case, you can use top. When we use take, we just put a number after it. When we use top, we place by after it. Then the field we're interested in. Think of it like a mix between take and sort. You can also use ASC or DESC after for ascending and descending order. Next up, we have extend. We use project to only display the fields we're interested in. And if we want to create a brand new field, we can use extend. Extend is powerful because you can define the parameters of what the field should be, and you can get creative with that definition. Here we're taking a sample of the perf table used to see performance metrics for Azure virtual machines. We see the time generated field in UTC. What if we live on the west coast of America, and right now the time difference from UTC is -7 hours? We want to display Pacific Standard Time in its own column. We can start by piping in extend. Next, we type in the name of the new field that we're creating. We'll just call it PST. We then use a single equals. This will help define what PST will contain. We want it to contain the time generated field -7 hours, so we can type it in just like this. When we run the query, we can see the difference between the two fields is 7 hours. We also want to talk about debugging. What happens when your query fails, or possible issues you may run into? When you write a query, it's possible for the query to function correctly, but return no records. In this case, there may not be an error at all. It just displays that there were no records found based on your search parameters. If this happens, you may have answered the question you were trying to find. But it may also be that there was a typo in one of your filters that needs to be changed. It could have one extra character, or an issue with the case sensitivity of a letter. Many of the filtering mechanisms we use are not case sensitive. One way to reduce the likelihood of this is using equals with a tilde to make it case insensitive. In the next example, we get an error message. When we look at the error message, it gives us a token, a line, and a position. These three items help us pinpoint the location of the issue in the query. Keep in mind, if there are multiple errors in the query, it may just point out the first error it finds. In this case, it's referring to line 2, position 2. Position 2 references the character number from left to right. Even though it's saying the pipe is the issue here, what really happened is we're trying to comment out the line and there was only one slash instead of two. When you get a line in a position, always consider what's to the left and to the right of the position as the potential culprit. When we fix the first bug, it identifies an additional bug later in the query because the product field doesn't have a capital P. We can also use the color coding system to help identify potential issues. You can see that field names are black, operators are blue, and strings are red. If we had a misspelling or error, it wouldn't have these colors in it. It points out that there's an issue there. When scanning your queries, pay attention to the color markings, and you can often find your errors. When we're working with numbers, they display as green. But if we comment out sections, they're also green. In the next example, we'll run a query to see records from the perf table. The query executes and everything looks fine. We see a warning bar above the result saying it's only showing the first 30,000 records. Keep in mind if the results are 30,000 in your log analytics workspace, the true number of records may be 30,000 or any number above that. If the question you're trying to answer includes how many records exist, it's better to use a more precise query like count. Study the next example for 20 seconds and try to find as many errors as you can before we run the query. There were 10 total errors in these 5 lines. Let's walk through each one, starting with line 1. When we start our queries, we often begin the first line with a data source. In this case, we're referencing the perf table. On the first line, we don't need a pipe, and the error message is pointing to line 1, position 1, and there's a red line under, helping us identify the issue. If you look further down the query, nothing else is underlined though. Sometimes we have to fix the first bug, allow the query to adjust for that fixed, and then it will help us identify the next problem. If you remember the color coding, you can already tell that some of the colors don't seem right for the type of word or symbol being referenced. As soon as we remove the pipe, we can see the red underlines populate in multiple locations. On the second line, we don't even need to run the query again to understand there's a misspelling of take. Let's fix that. As soon as we fix that error, the word take turns blue. Let's move on to line 3. Usually strings are red. When we have quotes around strings, we can use either single or double quotes. Whatever we decide to use, we must use for both sides. In this case, we've used a double quote to start with and a single quote to end with, and that's what's producing the error. Moving on to the 4th line, we see an issue with and. It doesn't need a pipe, and there's no issues with the spacing, but the capital A is giving the error. So let's fix that. Counter value is red as well. Can you spot the issue? In this case, it's referencing a field, and the field has a capital C and a capital V. But here we only have a lowercase v. If we didn't know the proper spelling, how could we find out? We know the query is good up until line 4, so let's comment out lines 4 and 5 and run the query. It says there are no answers, but that doesn't really make sense. Can you see why? Usually we take 10 after we filter, and in this case we took 10 and then filtered. We found the proper name of the field. What are some other ways we can find the name if we didn't know it? We can look on the left-hand column and type in perf in the search. And here we can see counter value. We could also type getschema to see it displayed. Do you see any other issues on line 4? When we use the exclamation point to negate something, we generally place it first. In this case, it's in reverse order. As soon as we correct that issue, the red underlines go away. Since 20,000 is a number value, it's green and there's no issues there. When we move to line 5, we see more red lines. We want to see the field in descending order, but DESC is the appropriate syntax. Even after we fix DESC, time generated is still red. Can you see why? When we use sort, we need to use sort by. When we run our query, we can see the results. And again, the maximum records displayed of 30,000, which lets us know it's likely not the true value. Don't worry if you didn't catch all 10 issues. It takes time and practice to get used to the language. As you get more repetitions in, these types of errors will jump out quickly. We've covered a lot of ground so far in the beginner course. If you found value in the content, please give us a like, and if you want notifications of more KQL videos, hit the subscribe button with the notification bell. If you want more practice on debugging, we have a 2-part debugging challenge at the end of the Beginner Series playlist. We also have a 2-part end of the Beginner Series quiz session to test your knowledge. We recommend taking the end of the Beginner Series quizzes to make sure you feel comfortable with foundational basics before moving on to the Intermediate Series. We'll cover summarizations, changing data types, pulling in external data sources, using variables, building charts and graphs, and joining 2 or more data sets together. In the Advanced Series, we'll focus more on parsing JSONs and using advanced functions. That's it for our KQL full course for beginners. If you want additional resources, the Microsoft Docs pages on KQL are great.